Okay, so now we start working on exam questions associated with trigonometry. Okay, let's begin with question 3. Okay, so question 3 says that in the diagram below, triangle QPR, which is this diagram, obviously you can see that. Okay, triangle QPR is a right angled triangle with angle QPR, this angle. Okay, being equal to 90 degrees. Okay, we can see all of that in our diagram. Okay, and then they say that use the sketch to determine the ratio of tan 90 degrees minus r. Okay, so this is angle r. Okay, and then they want 90 tan of 90 degrees minus r. So in other words, they are looking for tan of angle q. Okay, hopefully that is clear, because this angle plus this angle plus that angle will give us 90 degrees. Okay, so if they are looking for the tan ratio of 90 degrees minus r, it means that they are looking for the tan ratio of q. Okay, so this is how you will answer. So you will say tan of 90 degrees minus r is the same as tan of angle q. Okay, now we know that tan is opposite of adjacent. Okay, so the this will be given by side PR. Yeah, so this will be PR over PQ. Okay, PR over PQ, because PR is the opposite side, and then PQ is the adjacent side as far as angle Q is concerned. Okay, so this is PR over PQ. Okay, and then question 3.1.2, they say that you must write down the trigonometric ratio that is equal to QR over QP. Okay, so um, so QR is the hypotenuse, this side, and then so QR is that side, and then QP QP is this side. Okay, so we can look at this from the lenses of angle Q or from the lenses of angle R. Okay, if I look at it from the perspective of angle Q, then I can see that this will be sec of angle Q. Okay, the reason why I'm saying sec is because um, if I have QR over QP, um, QR is the hypotenuse side, okay, and QP is the adjacent side as far as angle Q is concerned. Now, we know that adjacent over hypotenuse is cos, but then hypotenuse over adjacent is the reciprocal of cos, which is sec, okay? So this means that this is equal to sec of angle Q, okay? So this is sec of angle Q, or we can look at this from the perspective of angle R. Okay, if we do that, we're given that QR over QP. Now, if we look at this from the perspective of angle R, we see that Q QR is still the hypotenuse, and then QP is the opposite side as far as angle R is concerned. Now, because of this, we have the hypotenuse over the opposite side, and this is the cosec ratio, because we know that opposite over hypotenuse is equal to sine, But then if we have hypotenuse over the opposite side, then that will give us the reciprocal of sine, okay? And the reciprocal of sine is cosec, okay? So this is cosec of angle R, okay? So um, your answer could have been sec of angle Q, or alternatively, you can say it's cosec of angle R, okay? Okay, and then we can go to 3.2. Now, in 3.2, they say that S is a point on the Cartesian plane. They give us the coordinates of S. Um, and then, so they say that S is a point on the Cartesian plane such that OS, okay, so this line OS makes an angle of theta with the positive x-axis. Okay, so this is angle theta. Okay, and OS is found in the third quadrant, as we can see. So before we even look at the questions, what we do is we complete the triangle, okay, because we will need this diagram to work on the questions. So do it like that, okay, and then we take the reference angle theta, we put it inside our diagram like this, and then we use the coordinates of S to 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 denote or to represent the lengths of the sides. Okay, so we know that this side is y, so in this situation we have -4, and then this side is x, which is -3. Okay, and then we can we can answer the questions now. Now 3.2.1, they want the length of OS. Now please note that they made a specific instruction. They've given a specific instruction that we must calculate the following without using a calculator. So we want the length of OS without using a calculator, and we will basically do this by means of theorem of Pythagoras, okay? Because this is a 90-degree triangle. So we know that OS squared, or we can just say OS is the same as the square root of negative 3 squared plus -4 squared, okay, and then what will happen, we will have 9 plus 16, and 9 plus 16, I think this is 25, and then square root of 25 is 5. So OS is equal to 5 units. Okay, so we have, this is 5 units, determined the length of OS. Okay, so now they want us to determine the value of sec theta plus sine squared theta. Okay, let's see. Sec theta plus sine squared theta. Now, this we can determine from our diagram, obviously. Now, sec theta is the reciprocal of cos, so it is um, hypotenuse over the adjacent. Okay, so our hypotenuse side is this one, and then the adjacent side is that one. So sec theta will be hypotenuse, which is 5 over -3, like this. Okay, and then sine theta, sine of theta is opposite of hypotenuse. Now in this situation is opposite over hypotenuse, so it's -4 over 5, but then they said this thing needs to be squared, so we can square it and then we can simplify. -5 over 3 plus 4 squared is 16, and then 5 squared is 25, and then we can we can determine the lowest common denominator by multiplying the two denominators. 3 times 25 is 75. Okay, and then um, we will say 5 times 25. Now, 4 times 25, that is equal to 100, and then plus another 25, that is 125. So we have minus 125, and then 3 times 16, 2 times 16, that is 32, plus another 16, that should give us 48. Okay, so this is 48, and then we can simplify this further. um Minus 125 plus 48, what will that give us? um 48 minus 25, that should give us 23. Okay, and then 100 minus 20, that should give us 80, and 80 minus 3, that should give us 77. So the answer is negative 77 over 75. Okay, so this is our final answer. So this is the answer for 3.2.2. So it's negative 77 divided by 75. Okay, and then we go on to 3.3. Okay, so in 3.3, they say that we must determine the value of the following without choosing a calculator. Okay, so we see that we have cosec of 45 degrees, and then divided by sine of 90 degrees times tan of 60 degrees. Now we can see that all of these are special angles. Okay, and we know that if we are given special angles, then we have to make use of graphs, and also we have to make use of special triangles. Okay, so we will recall that um, one of the triangles, this is the 45-degree triangle. Okay, so 45 degrees, 45 degrees, it's 1, and then this is root 2. Um, and then the other one is the 60-30 one. Okay, so this one looks like that. Um, okay, so this 60, this is 30. Okay, this is 2, this is 1, and this is root 3. Okay, and then we can see that we have sine of 90 degrees. That means we will need a sine graph. Okay, let's draw a rough sine graph. Okay, so sine looks like that. We go up, we come down, and yeah. Now we know that this is 90, this is 180, 270, 360. Okay, this is 180 degrees. Okay, now these are the diagrams that we will use to evaluate the expression that they've given us. Now, cosec of 45 degrees. Okay, now cosec of 45 degrees, cosec is the reciprocal of, it is the reciprocal of sine theta. Okay, of 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 sine of an angle. Okay, so sine of 45 degrees is 1 over root 2. Okay, because sine will be opposite over hypotenuse, so it will be 1 over root 2. But then, because we are looking for the reciprocal or cosec, now we have to 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 flip things around, so it will be hypotenuse over the opposite side. Okay, so it will be root 2 over 1, which is equal to root 2. Okay, so this will be root 2. And then sine of 90 degrees. So this is 90 degrees. So we basically go upwards. We know that this is where sine has its maximum value, and that maximum value is basically equal to 1. Okay, and then tan of 60 degrees, we go to this triangle, and then we say opposite over adjacent. Now this is root 3 over 1, which is basically root 3, like that. Okay, so this can be simplified, and we have root 2 over root 3, and then we can write it like this, 2 over 3, like this. Okay, so this is our final answer. um this is our final answer, and if you like, you can rationalize the denominator. Okay, let's do that. So our answer is this one, root 2 over root 3, but then we can rationalize the denominator to turn it into a rational number. Okay, so you can multiply the top and the bottom by root 3. Okay, so essentially we are multiplying the fraction by 1, so we are not doing anything illegal. Okay, so we know that if this happens, then we have 2 times 3, and then root 3 times root 3 will basically equal to 3, and then this will be like that, root 6 over 3. So this is our final answer in its rational form, or the denominator in its rational form. Okay, but then if you left the answer like this, you will still get all the marks. The thing is, this one looks a bit nicer or neater, so to speak. Okay, so um just for yourselves, you can draw these small diagrams on the side as you are working with these things, and there's no need to erase them. Okay, as a proof that you didn't use your calculator, it is actually a good a good practice to just draw them on the side and leave them like that, so that the